Okay, Assalamualaikum warahmatullahi wabarakatuh and hello. So for today we will learn about chapter 9, which is metric algebra. So in chapter 2 we already learned about this. This is just to recall what we have learned on metric algebra, and also we have a little bit of additional knowledge. Okay, there will be attendance provided in the middle of the video, so don't forget to slide in your attendance. So our objective today is to introduce several MATLAB algebra function to solve engineering problem, and I will show you dot product, cross product, inverse, and determinant of metric, and also I introduce others metric function that can be useful in engineering problem. Okay, MATLAB is originally written to provide an easy interface for linear algebra subroutine. Okay, it's offer a wide range of metric algebra function that can be used to solve engineering problem. Okay, so some engineering problem can you using the metric and some using array. So you have to identify the problem. Okay, identify the solution, understand the solution, and try to make sure that you know which either array or metric is used to solve this problem. Okay, if you refer back, okay, metric, okay, when you learn about metric, you can either be a dot product. Okay, in MATLAB we use a symbol dot, or we can see a cross product. In mathematics we use a cross sign, okay, or X sign. So there are two types of metric multiplication, and also we also need to learn about the inverse metric and also the determinant. Okay, we also will learn the linear to represent. Okay, dot product we present with dot. So I give you a simple example. Don't forget to test this and submit it in e-learning. Okay, example 9.1. So you have u, you have v. So dot product, you can see here it use dot. So what it means by dot product is this one will be multiplied with this, and then plus this one multiplied with this, and then plus this one multiplied with this, and then plus this one multiplied with this. So you can see here, this is the output. As a result, the dot product usually becomes something like this. Okay, it will not give the answer in the original form. Okay, it will change. Okay, in MATLAB, either metric multiplication operation or dot can be used. Okay, you can use either this one or you do this one. So how to use this one? Okay, and this one. So in MATLAB, you use, for example, you already define this. Okay, if dot product you use star and v. So this one you already learned. And another way to write this, you write dot, then u and v. Okay, this is the same thing. Okay, you can use either. Okay, if you want to calculate the dot product, okay, when it comes to dot product, the metric needs to be something like this. Okay, other than this metric, you cannot do a dot product. So basically what this means that the metric needs to be horizontal first and then vertical. Okay, 1 multiplied by n, so 1 is means one row multiple n, and then you have this one. Okay, so when it comes to dot product, make sure your characteristic is this one. Okay, make sure this one, and the result will be 1 multiplied by 1 metric. Okay, just a magnitude or a scalar metric. Okay, means that 1 multiplied by 1. So make sure of that. So I give you a second example here. Okay, angle. Okay, based on we using your dot product. Okay, the dot product, to get the angle and the magnitude of the two vector. Okay, you have vector 1, you have vector 2, you want to know, okay, for example, you have this is vector 1, okay, you want to know this is vector 2, you want to know what is the angle and the magnitude, A and B, right? Something like this. So the formula for this, if you recall back your metric learning, okay, the angle is cos inverse u dot v divided by magnitude of u multiplied by magnitude of v. So how to calculate this? Of course, the square root of u1 plus u1 squared plus u2 squared plus u3 squared. Okay, something like this. Okay, for you, okay, it's not important to understand the problem. Okay, when it comes to programming, it's not important to understand the problem. But the important is you have to understand the solution, how the solution works. And based on the solution, you have to create a program. Okay, you don't need to understand this. Okay, usually we will give the problem. Okay, you need to understand the problem, the solution, not the problem. So how the solution work manually, and then based on the manual calculation, you have to transfer the manual calculation into a programming. Okay, so I give you example here. You have u is this, v is this. Okay, so how to compute? Okay, how to find the angle? Okay, now we try to understand how the coding works. Okay, so if you see here, okay, you want to get the angle. So how to get the angle? So if you look back this one, the coding, you make square root of u multiplied by u bar. Okay, so what it means that, okay, you have u magnitude is below here. Okay, this one is the u magnitude. So you can see here, u magnitude is basically u multiplied by u bar power of this one. Okay, so remember the dot product here. Okay, you have u magnitude is u dot u bar, okay, and then you square it. Okay, square root. Okay, so that's why if you check back, the coding is basically u magnitude is equals to sqrt or square root u dot, or in this in MATLAB you use this one, u bar. Okay, so you don't need to understand how to solve this. You don't need to understand how the problem, but you need to know how to solve this. Okay, same with v. You can see here the v. Okay, use the same concept, because to get the formula here, okay, you need to u magnitude of u needs to be multiplied by v. Okay, so v mag, of course, sqrt v v. Okay, so that's why the second code is right. Okay, and then of course you can see here at the top, u multiplied by v, the normal dot product. Okay, so to do this, you can see here u dot v, this is for the top. Okay, and theta, of course, if you look here, this one is cos inverse. So cos inverse in in MATLAB we use, okay, a cos. Okay, a cos. So theta is just equals to a cos uv. Okay, basically we call back this one, and then we multiply the u mag and v mag. Just integrate back the formula. Okay, and then this one in degree, basically a cos, okay, whatever cos of sine you use in MATLAB, it's basically use radian. So be careful, not degree but radian. So anything you calculate in MATLAB using cos function, it is in radian. If you want to use degree, you have to use different code. I forget the name, but I think this cos d, okay, tan d, something like that. Okay, you have to check using Google. Okay, you try to Google it and make sure you know. But the original one is in radian. So of course theta needs to change to degree. Okay, and then you print it. Okay, remember the input output chapter 6 if not mistaken. So you just print out the result. Okay, remember that I said star is, okay, when you have some value here, okay, you have some value, okay, if not 1, okay, it is a multiplication. Okay, that one I forget to mention. So dot product is basically only this one, okay, this type of metric. Okay, you need the function needs to be vector, okay, to produce a dot product. Okay, something like this. This is a vector. So 1 multiplied by n or n multiplied by 1. Okay, make sure when it comes to dot product, to solve the dot product, you need to make sure that it is a vector and not a array or a scalar. Okay, so be careful. So if you don't have this kind of metric, it is not a dot product. It is just a metric manipulation. Okay, for example here you can see here, you multiply by v and then you get something like this. So basically this is the error that you seen before. Okay, so be careful. This one is different for MATLAB 2017 below. Okay, for MATLAB 2017 below, okay, it will show different result, but for this case it will show this. Okay, so how is it? So u bar, so basically 3 4 5, okay, u bar, okay, or u inverse, and then multiply by v. Okay, so v is 1 1 1. So what happened is basically you multiply 3 with 1 1 1, so 3 3 3, and then 4 multiply 1 1 1, so 4 4 4, and then 5 multiply 1 1 1, so 5 5 5. Okay, so it will become like this. So make sure if you meet something like this, it is not a dot product. So dot product is basically something like this and something like this. Okay, so this format. So be careful. So you can try this. Okay, dot product also can be used to simplify the code. Okay, so recall back example 4.1c chapter 4. Okay, this one is the compound. Okay, the compound interest. So remember b is equals to, okay, b is equals to a multiplied by, okay, multiplied by 1 plus r. Okay, r is the interest, and multiply by dot n. Okay, this one is basically the number of years. So you have r is constant, okay, n is constant, okay, okay, for this case n is multiple value, okay, and you have to use a mesh grid. In chapter 4 you use mesh grid. Okay, so basically the mesh grid will create a array, okay, and it will multiply using a array operation. Okay, remember the dot. Okay, so but instead of using array operation, okay, you can simplify this code by using a dot operation. Okay, so if you look at his, okay, look at this. So 1 plus 0.09 is 1.09. Okay, let me use the pen. Okay, for this case only, okay, look at this. Okay, 1.09 multiply by, okay, not multiply, power of, sorry, 1.09 power of 2, 4, 6, 8, 10. Okay, so basically you have answer multiple, okay, multiple answer. So why? Because you use a array operation. So you have 1.09 power of 2. Okay, let me, okay, a bit confusing right now. So you have 1.09 power of 2, and then you have 1.09 power of this one 4, and 1.09 power of this one 6, and so on. So you have matrix something like this. So you have A is this. So your A is 100, 500, 800. So you have something like this. You want to get the answer, okay? But instead of using a dot, okay, which is you can use it also, but you can use this. Okay, you invert this, so the line should become like this, and then you multiply like this. Okay, you inverse this, you get 100, 500, 800 multiply by 1.09 power of 2, and so on. Okay, and you also will get the answer, but the answer will not be the dot product, so be careful. Okay, remember that I said that you can use either the star, okay, and the dot. Okay, dot, open bracket, close bracket. So this is how to use the second method, dot. Okay, so when it comes to dot, make sure, okay, you can remember that this one multiply by this one if you use star. But for dot function, make sure, okay, if you look here, both needs to be horizontal. Okay, when it comes to dot function, make sure your both value needs to be horizontal. So make sure you be careful with this. Okay. So I give you another example of center of mass. So when it comes to center of mass, okay, you don't need to understand how to do it, but you need to understand how the solution works. So if you can see here, to get the center of mass, you have the length here of x, y, and z, and of course you have the mass. Okay, so basically how to get it, you use a dot product and sum of mass. Okay, this one is just normal sum of mass, you just sum everything up. But for this one, you have the dot function, dot metric. Okay, so how to do this? Okay, so you have x here, okay, you have m. So how to do the dot? So you list down all the x. So you have, see here, this is all the x. So x is 0.1, 1, 1.5, and okay, 2. Okay. Okay, how to do the dot product? Okay, of course you need to have the mass rearranged as a vertical one. Okay, so 3.5, 1.5, 0.9, okay, 79, 1.75. So you see here, this is a dot product of x and m. Okay, this is the dot product. So same as here, but for this one you replace it with the y value. Okay, don't forget y value needs to be horizontal and m value needs to be vertical. this one is horizontal. This is how you can use a dot product. Okay, same as here. Okay, that one is how to get the center of mass. But how about we can simplify it more? Okay, using dot product. Okay, so to do this quickly, okay, you can see here. Okay, you combine all the x, y, and z. Okay, so the dot product. Okay, basically you solve this one with all of it. Okay, this one, this one, this one, this one, and then you solve y, also multiply by this one. Okay, the same approach, but this one is much more simplified. This is also the dot product, but this dot product is more to I will obtain 3 answer. It's not like a real dot product, but you combine it so that MATLAB can do it easily. Okay, basically this is a dot product seen by the MATLAB. Okay, so you can see here the operation is still the same, but you will get 3 answer automatically. Okay, then after that you can use this to get the center of mass. Okay, which is just add all the mass. Okay, you divide it and you get the answer. Okay, don't forget to divide the total mass. Okay, so based on the solution given, so you have to transfer the solution into the MATLAB code. So of course the mass, this one is the mass. Okay, so this one is the x, y, z. So you can see here all is it is in horizontal. Okay, if you look here, the mass should be in vertical, but no need to worry. Okay, we can invert it later. Okay, so dot. Okay, this one and this one. Okay, so for this case, okay, if you use the dot one, you don't need to put the inverse. Okay, so remember that I said when you use the dot, okay, instead of the multiplication, something like this. Okay, you don't need to make sure that all of it is one is horizontal, one is vertical. So for dot, you have to make sure that all of it is horizontal. Okay, so when it comes to here, automatically if you use dot, automatically this one will become vertical. Okay, so make sure of that. And then this one, of course, sum is basically sum all the value inside this variable. Okay, so you have x bar, y bar, z bar, and then you can print the result. So the coding is much more simple. Okay, if you use dot function. Okay, if you don't want to use a dot, okay, you can use the star. Okay, so if you want to transfer the problem mass center of mass into the MATLAB code, first you have to, of course, write the mass. Okay, so then write the P. So remember, so this is the x. Oops, let me delete that first. Okay, so this is x, this is y, this is z. So actually you can, instead of using the semicolon, okay, something like that, you can just enter. Okay, when enter, it will create a new row. Okay, automatically when you enter, you will create new row. You don't need to use the semicolon to represent the new row. So you just use like something like this. Okay, so and of course don't forget to inverse it. Okay, not inverse, transpose it. Okay, transpose the metric, because this metric is in horizontal. So make sure you, when it comes to dot product, you have to make sure the second metric needs to be vertical. Okay, and then of course divide by sum m. So automatically you get the answer. Okay. So the result, you can use plot function, okay, to see the center of gravity. Okay, pause the video and slide in your attendance. So let us move on to the next type of metric, which is the cross product. So if you recall back, okay, the C multiplied by C is equals to A cross product B. So if you see something like this, okay, basically C is perpendicular to A and B. Okay, you can see here, you have A, you have B. Okay, A is the index finger. This one, you have to use the right hand. This one is right hand. Okay, right hand. Okay, and B is this one, middle finger. Okay, index finger, and then the thumbs will be the direction of C. Okay, C needs to be perpendicular. Okay, and how about the magnitude? Magnitude, basically you have to use this. Okay, A dot B sine theta. Okay, the angle between A and B. Okay, so the angle between A and B is theta. So the highest, okay, magnitude is when A and B is perpendicular. So you have A and B. Okay, you have A, you have B here. Okay, if it is perpendicular, the magnitude C is the highest. Okay, if it is parallel, A and B, A, B is parallel, C magnitude will be 0. Okay, remember, use right hand rule. Okay, A is the index finger. Okay, I forget the name. Okay, so make sure you know the cross product rule. Okay, and how to write it in MATLAB, you use the cross coding. Okay, cross. Okay, cross product is very useful in magnetic force. Okay, when it comes to magnetic force, maybe in your 3rd semester or 4th semester, you will learn about the machine. Okay, or electromagnetic theory. Okay, so you will use this cross product. So you can see here in example 9.7. Okay, so you have a current here moving 20 milliampere, okay, to the direction x. That's why it is 100, because it's moving to x. And you have the magnetic force, okay, magnetic field. Okay, you have magnetic field, B is magnetic field, okay, in the direction of 0.25, 0.25, and 0.2. Okay, this is 3D. So this is the direction. Okay, so what is the force of what is the direction of the force of the wire? So basically this is a motor. Okay, so the wire will move. So this is the force. Okay, so when a wire length carry current through a magnetic field B, okay, the force exerted by the wire is this. This is the formula for magnetic force. Okay, basically a motor. Okay, this is a theory of the motor, electrical motor. So F is equals to I, okay, which is the current. L is the length, okay, multiply by B, magnetic field. Okay, this is the cross product. Okay, so the force is calculated using this formula. Okay, and of course the direction, okay, the direction is always 90 degree of the L and B. Okay, this is L, this is B, so this is 90 degree perpendicular to A and B. So if you recall back the problem, the wire goes to X. Okay, so 100. Okay, the magnetic field is this one already given, and current also already given. So to get this is LB, okay, the cross product of LB. So you just use cross LB, okay. So you just insert the value, okay. So make sure all is horizontal, both is horizontal, and then you have to multiply by I, and of course you recall back the formula. You have to make sure that is the cross product, okay, needs to be absolute. So to get the magnitude of the L multiplied by B product, you have to use a magnitude vector, okay. So how to do this? Use norm, okay. So you use norm, this is the code, norm multiplied by I, you get the F, okay, the force. So the theta, of course, you use the formula, okay, the dot method, okay. Okay, this one is the cross method. So how about the dot method? So basically you use the, okay, if you look here, so cos A cos, okay, dot LB divided by norm L and multiply by norm B. So remember the formula in the previous example 9.2 if not mistaken. So you just multiply this, okay, you get the force and the angle, okay. You use the dot method, okay. So we continue with metric inverse, okay. So this is basically some properties of inverse metric you have to recall back. So how to write it? You use this one, don't use this one, okay. So another properties is inverse of the scalar multiply with the scalar is equals to 1, okay, this one, okay. A inverse multiplied by A is 1, okay. Multiplication of an inverse metric to the original metric is an identity metric. So remember back what is identity metric. So only square metric, okay, with size of okay, means that it is a same size, okay, 1 1 or 2 multiplied by 2 or 3 multiplied by 3 has the inverse metric, okay. And singular metric doesn't have an inverse, okay. So singular metric doesn't have inverse. So how to write inverse metric in the MATLAB? You have three ways. Either you use the code inverse, or you can use -1, a power of -1 here, or another one you use back, okay, backslash, not the slash, this is normal slash, so backslash is this one at the top of the enter button. So a power of b, okay, a inverse b, so you have to write something like this, okay. Don't put this one, you put the backslash. Okay, like we look at example 9.8. Don't forget to try this in your MATLAB and submit it in e-learning. Okay, for example, you have A is this one. Okay, if you use this type of code, you have to use INV inverse. Open bracket, A, close bracket. So if you inverse this, you get this answer. Okay, another way is you use, okay, the head, okay, -1. So you use this one, you also get the similar answer. Okay, another approach is to use this one, okay, the backslash. Okay, so a backslash, okay, or using a left division operation, okay, and then multiply by 1 1, okay. Because you just want to inverse it, you just use 1 1, okay. So you get the answer, but the answer is a little bit different, okay. Don't forget this. Okay, another important metric that you can use is determinant, okay. So how to do this? You can use DET. Okay. So, or you use this. Okay. So if you recall back, for 2 by 2 matrix is much more simple to get the determinant. So A multiplied by D minus C multiplied by B. Okay, this is how to get the determinant. So for if you use a matrix, okay, it is very useful if you have 3 by 3. Okay, 2 by 2 is simple, but 3 by 3, okay, remember you have to close this, multiply this and this and this, and then close 2, and then you have to multiply 4 3 multiply by 1 6 and 3, close 3, and then multiply 4 2 minus 1 3 multiply by 3, and then add together. So it is quite difficult to do matrix larger than 2 by 2. Okay, so to get the determinant you can use MATLAB easily, so you just use this one. Okay, so for this case, if you you find the determinant of this one, okay, you get 0. Okay, singular matrix is a matrix that doesn't has inverse. A matrix said to be singular matrix if the determinant is equal to 0. So this is a singular matrix. Okay, this one has no inverse. Okay, inverse is 0. So what is the function of using determinant? Okay, one of it is to find the area of triangle. So you have determinant, this one, divide by 2. So this is the formula. So you have the xy location for 1, xy location for 2, xy location for 3, and the rest you put 1. So how to do the code? So example 11, so you just insert the determinant, okay, the matrix of all the determinant. So you get this, and then you find this, you get the area. Okay, try it yourself. Okay, next example is the linear equation. Okay, how to solve linear equation using matrix. So remember this one, okay, usually you use your calculator. Okay, your calculator also can use to solve this. So beside that, you also can use the MATLAB. So this one is the equation example. Okay, this one is how to write your equation inside a matrix and how to solve x. So basically you transfer a into here, you get a inverse, then multiply by y value. So basically when you want to transfer this equation into MATLAB, you just use backslash. Okay, this one. So how to program it? So you have PA, of course. This one is x1, y1, z1. This one is x2, y2, z2. This one is x3, y3, z3. Okay, and this one is the y value. Okay, so make sure this one you have to make a column vector. Okay, means that y needs to be vertical matrix. Okay, so you get this. So basically you just backslash it and then you get x. So much more easy to use MATLAB, especially if you have a simultaneous equation larger than 2, 3, 4. Okay, 4 is much more useful because your calculator or the newest calculator only support until 4 if not mistaken. So if you use MATLAB, you can solve it easily. Why this is important? Because of circuit analysis. Okay, you remember circuit theory? When it comes to circuit analysis, you have simultaneous equation with multiple current, for example. So you have I1, I2. This is only two loop, but how about multiple loop? So it is harder to solve. But if you use MATLAB, you have the equation, right? You just transfer this value inside the MATLAB. So this is the code. Okay, so you see here, this is the code. Okay, and then this is the voltage. Okay, so of course you need to make sure it is a column vector, and of course you use the backslash. Okay, and you get the current. Or another way, of course, you remember the invert. Okay, invert R, so you can use that also. It will show the same answer. Okay, we move on to the last part, which is a useful metric function. Okay, so this is some function you can use, okay, for metric. Okay, so cat concentrate array along specific dimension, horizontal cat, vertical cat, repeat mat. Okay, repeat metric means that you repeat the metric again and again. So you also can use sort, which sort the metric, okay, or sort the row. This one is flipping the element inside the metric, okay, and then compute compute the sum of element on the main diagonal, okay. Okay, another special one is once. Once is basically you create a metric that contain only one. Okay, 1 1 1 1 1 1. So you have to insert the value lah. What is the size of the metric? Okay, so zeros, of course, the same thing, but it's 0. Okay, 0 0 0. Okay, identity metric. Okay, remember about what is identity metric and magic metric. So this is the useful metric function that you can use. Okay, so for a first example, let us use trace. So trace is, remember what is trace? Trace is basically you add everything inside here. Okay, so basically B is sum of the diagonal. So 1 plus 5 by 9 is 15. Okay, the next example is I. Okay, I is just basically identity metric. So remember, identity metric is the diagonal is 1. Okay, remember something like this, and 1 1 1 0 0 0 0 0 0. So basically identity metric is just all 0 except the diagonal is 1. So that is identity metric. So how to create this? You can either use a manual way, which is quite tedious, or you can just use I. Okay, so why you want to use this? Okay, for example, if you have some function like this where a and b is 2 multiplied by 2 metric and x is 2 multiplied by 1 metric, so instead of having 2 multiplication, the equation can be arranged as below, as where I is 2 multiplied 2 metric. So basically you just use this, just extract this outside. So when you come to metric, you have to put the identity metric. So how to do this? You use I to to put the the function I, the variable I. Okay, so you can see here, this is a 2 by 2 function and x is 1 multiplied by 2 function. Okay, this is the manual way. Okay, you can get the answer also, or you can use the I. Okay, you can see here, I2 means that 1 1 0 0. So 2 means that the size of the metric is always, okay, square metric. Okay, means that the m multiplied by m metric. Okay, so if you look here, you still get the same answer because you use the identity metric. Okay, And also make sure, okay, you don't use 1. Okay, 1 is not the same. Okay, that's, you can see here the answer is not the same. Don't use 1, use identity metric, okay, when it comes to metric multiplication. Okay, that's it for today. We have concluded chapter 9. So we have learned, okay, I have introduced several metric algebra functions to solve engineering problem. Okay, so I show you the dot product, of course the cross product, the inverse, and of course lastly the determinant. Okay, so I show you where we use this. For example, this one is in, okay, cross product in motto, okay, F equals to B, okay, LB, okay, and then dot product, and then determinant, where to use it, okay, inverse metric, where to use it, okay, and then also show you the other metric function that can be useful in engineering problem, such as I and, okay, trace. Okay, so for others you can try it yourself. Okay, there are many metric function that available in MATLAB. So that's it for today, and don't forget to check in your attendance at the middle of the class. Okay, thank you.